All right. So let's go into our first section. We're going to be working kind of with the relationships in triangles, like more the number stuff than the proof stuff. So first of all, our first topic is going to be on what's called a midsegment. So let's go write that up here. Midsegment of triangles. So we're going to work with two things. We're going to work with the sides, and we're going to work a little bit with the angles, but a midsegment connects midpoints, two of them, of two sides of the triangle. So if you were to get in the middle of one side and then go and get in the middle of the other and connect them, you would have what's called a midsegment. So I'm going to go grab my highlighter and I'm going to highlight that midsegment. You might want to highlight in this chapter just because these triangles have lots of stuff on them. It's easy math, but there's just a lot on them. So that guy right there in yellow is called a midsegment of the triangle. There's actually three of them because I could have connected these two as well. Don't you do that? But that would also be a midsegment. But on this one, segment DE would be called a midsegment. So I'm going to go point that back. There's two things that happen with sides when you draw a midsegment. The first one is this highlighted one and the side of the triangle across from it over here will never ever cross. If I extended them forever, what's the word for that when two lines never cross? Parallel, yeah, you got it. So the first piece of math is that the lines, the midsegments, are parallel to their opposite side. That's the first property we're going to work with the midsegment. The second is about its length. Okay? If you were to measure them with a ruler, if you were to measure the midsegment, suppose that was 6 inches long, and if you were to measure that side across from it, it will always be double. So there's actually two relationships. This theorem for midsegments actually says that the midsegment is half as long as the big one. But you could also say that the long one, AC, is twice as long as the short. Wouldn't you agree? So there's two relationships. Last hour I was calling the midsegment the short side, so we'll put a little S on there. Oops, that doesn't look very good. We'll put a little S in there. And I was calling the side of the triangle the long side. So I kept talking about short and long instead of midsegment and triangle side. It was hard for me to say. And it worked really well because I could tell them these two things. The short is equal to 1/2 of the long, like when I have the 6 and the 12. Or I could say when I double the short, I get the long. So you could think of it two ways. Like if we were talking about our ages, I could say, oh boy, I'm way more than double your age, but let's pretend I was in my 30s. I'm a few decades beyond that. But anyway, I could say I am twice Brody's age, or he's what? Half mine. So it can work either way. One of them is nicer when you're doing the algebra. One of them will keep you from having to work with really messy fractions, and that's this one. So I think you should put that in a box and kind of highlight it. If I were making a note card, I would choose to put twice the short side equals the long side because it's easier to double 11 and work with the 22 than take half of it and work with a fraction, correct? So we're going to gear ourselves towards that twice the short. So it says in the diagram above, we've got two things we could say. I could say DE is running parallel to the side across from it, which was segment AC. So that's the first thing, that we've got parallel sides. The second was their relationships. And I'm going to choose this one right here. I'm going to point an arrow at that one. I'm going to say 2 times my short side, which is from D to E's length, is equal to my long side. I like that one better. All right? So we're going to go practice those two right now on the next page. We're going to practice the parallel relationship, and then we'll practice the numerical one. If you guys are participating, I won't go through all these examples. There's a lot. So let's see how we do. First thing says to identify all pairs of parallel segments. So each one of these things, keep in mind it's called a mid-segment when it hits in the middle, is parallel to the long side on the triangle across from it. So those two are running parallel. So I would just say XW is running parallel to RS. Go write another one down for me, will you? Pick another mid-segment. I'll pick another highlighter color. Look at it. I don't care which one you choose. It's going to run parallel to the one across from it. Okay? So that WY will run parallel to, I'm going to write that, the one across from it. What's that, QR? Okay. What's the very last one I would write? What do you think, guys? XY, yep, running parallel to what? QS. So I'll go do that, all right? So XY is going to run parallel to QS. So are we good on that relationship? Right? So I think over here, let's change this to one pair. And let's cross off these two blanks and just go ahead and pick one of the three pairs. If you can pick one of the pairs, you can pick all three of the pairs. And it's easy. All you're going to do is grab one of the short sides, head across. It runs parallel to the long side across from it. Okay? Read what short side you want to pick in here on this little mid-segment triangle in here. He's choosing JL as his short length on the mid-segment. So he's choosing JL as his mid-segment. Who does that one run parallel to? Reed, go ahead. Yeah, and thank you for heading all the way across. All right, so pretty easy with that. The next thing we talked about is the relationship between their lengths. You can see that these two obviously aren't equal, correct? And I told you twice the short is the long, or I can take half the long to get the short. Just depends on what I want to do, okay? So they're going to give you some information. Let's see what we've got. They're giving you P to R is 46. So you're going to have to go on the picture and decide if P to R is on the mid-segment triangle or the original. P to R is this whole way. So I'm going to block off this whole length and put a 46. So I've got 46 on that whole length of the triangle. P to Q is also an entire length. It's over here. So they're now giving me another long guy. P to Q is 40. And L to N actually is one of the mid-segments, so be careful what they give you. That was one of the issues in Delta Math. I was like, oh, they were talking about the sides. Those are angles, so be really careful with that. And then I have a 17 here. So they gave me three lengths. I did them in blue, green, and red. Let's go take a look at what it asks me for. First question, I'm supposed to get from L to M. Okay, that's this guy right here. Go ahead, somebody knows. What is it? 23. Thank you. It's half the one across from it. That one's done. Okay. The next one I'm supposed to get from M to N. Actually, I'm going to go put that on here too because I think I'm going to need it later. All right, so I'm going to go put a little 23. So now I've got two legs of the big triangle and two on the mid-segment triangle. This one's asking me for the third one on the mid-segment triangle. Go ahead and blurt it out. What is this M to N going to be? I hear it. What is it? 20. It's half the one it's across from. Okay? So this guy over here is going to be 20. The last thing it asks me for, it also asks me for, sorry, Q to R. Now take a look. There's lots going on here, so I'm going to go like this. Q to R is this guy that I'm squiggling. It's a long side. I know it's twice the short side across from it, correct? You see me squiggling on these? So what is Q to R going to be? 34. Thank you guys. 34. And last up, remember they said that these are the midpoints. So if 34 is this whole way across right here, how far is it going to be from just M to R? 17. Thank you. All right? I want you guys to go try number 4. I might not give you enough time to get all the pieces, but again, read these very carefully right here. Go label them. They'll either be shorts or longs. They'll help you get the missing other 3. You'll either be doubling them or cutting them in half. looks like on this one they're giving me 2 shorts and 1 long. So go ahead and try it. When I'm recording, I don't give you as much time to try just because. So let's go start. You should have said, well, F to G is 9. If I know that one's 9, what other one can I go fill in right now? If this guy's 9. What one will I know? D, E. Yep. Again, that one's going to be double the short to get the long. So it looks like I had D, E right away. And the next thing it says is from G to H. That's another short one. I'll do that one in green. So from G to H, it says is 7. What other one do I know right now?
C to E.
I do. I know C to E. What's it going to be? 14. Perfect. So I'm just kind of going one by one here. And then they gave me a long one next. They gave me from C to D. That's this whole guy in blue. And they said that whole distance is 24. Well, that's going to help me get the one across from it, or the short one. So what's F to H? 12, we got it. Now, perimeter, what does it mean when we have that word perimeter? Add up all the sides of which triangle, the big one or the small one? Big, yeah. Triangle CDE is this whole big triangle. So I'm going to add up all the sides. I need to do 24. Someone can do the arithmetic for me. 24 plus the 18 plus the 14. 56? Yep, thanks, sir. So 56. All right, so just to recap what we've got these things called mid-segments. Right now we're giving them 2 properties. They're parallel to the side across from it, and they are half as long. So now we're going to go in and work on that with some algebra. All right, so you have a short side. I'm going to label it short. Okay? And I'm going to label this one long. This is actually called a mid-segment. What's this called? Mid-segment. This is called the side opposite it. But I like to call them short and long. It's easier for me to help you. All right? Now, when you're doing the algebra, you have 2 choices. You could say the short, like Brody, is half my age, right? Or I could say that the long one is twice the short. I've got odd numbers in here. So do you think I'm going to want to be doubling or cutting them in half? Doubling. Yeah, so I'm going to choose to take that short length, double it, and set it equal to the long. All right? I could do it the other way. I get the same answer. I just hate fractions. So when I do that, I'm going to go 2 times. I'm going to put the short in parentheses. Where am I going to put it? For this one, it doesn't matter, but for this one over here, it will. All right, so just go ahead and, I would even write it like that. It's going to equal 17x minus 18. And then we just have to do the algebra, and you guys are pretty good at that, so I probably won't talk through all of the algebra with you. But we've got a 14x equaling 17x minus 18. What do we do when that variable's on both sides? Subtract. Yeah, you can either subtract 14 or 17, but I think on this one I'm going to choose to subtract 17. Watch your signs, right? I'm subtracting, so I'll be down 3. And over here I have negative 18 left. So on this one, what's x? Positive 6. And did it ask me for x? Yes. All right, sometimes it doesn't though. All right, so I want you guys to go set up number 6. Be careful, because last hour, some of them, they did choose to do twice the short equaling the long, but then they only doubled the 6. So that's why with you guys, I think I want you to parenthesize that and throw the whole short side in there. Go ahead and do it. I remember the answer from last hour, so if most of you have it right, I think we'll fail on this skill and move to the 3rd one. Okay, so go ahead and solve that. 2 times the short side equals the long side. Hey, when you have parentheses, what's your first algebra step? What's that called? Distribute. Yep. Step 1, I would double the short. set it equal to the long, because I don't want to work with half of 19. I suppose all of even, I don't care. That is correct. We'll have the right answer once you get out your calculator and divide that. It's looking good. Alright, because I'm recording again, I'm not going to give you as much time, but most of you got a good start and some of you even had the right answer. So again, twice the short, so go ahead and make sure you put the whole thing in. When we distribute, we get 12x plus, that looks like 62, right? 15x minus 36. Who haven't I put down for a long time in here? Sydney. What do I do in this scenario? Yeah, she said get the x's on one side if you're listening to the video. I don't like working with negative numbers, so I'm going to choose to move that 12x over. It looks like I get 7x minus 36. Oh man, what do I do next to solve that for x?
You add those two.
Thank you. Adding 36 is going to give me 98. Equaling 7x. If here you got it this far, I should take out your calculator and then let's get. Alright, and does it ask for x on this problem? Yes. Alright, so lots of algebra. If you like algebra, chapter 5 is your gym. Because there's a lot of it. So let's go to the next page. And I think I'm okay skipping this one for now. Don't cross it off. We might come back to it if the homework looks kind of bad tomorrow. I might come back and do some more. But we'll start this one and not finish the algebra. I want to make sure you can set it up. Okay? So set up your equation. And we might not even finish solving it. Are you guys pretty confident with your algebra for the most part? I think so too, so I don't want to waste your work time. If you need more help on algebra, certainly ask, but I think I got most of you are rock solid with that. And again, you have two options. You could cut this side in half and set it equal to that one, or you could take this short one and double it. Which one did I say is easier? Doubling the short, yeah, thank you, Brayden. So I would again, maybe on a note card, even for mid-segments, write 2s, I put it parentheses, equals the long. Which one's the short side up here, Gav? Yep, PQ. 15x minus 17 is going to go in for that short side. The long side I highlighted over here, 23x minus 6. All right, let's pick out a few new people. Jacob, what am I going to do first to solve this, sucker? Distribute. Yep, perfect. I'm repeating because they can't hear you on the video. Like, why does she keep repeating everything? It's picking it up from over here, so. Perfect. I'll get it this far, and then let's head to the back. How about Carter? What's next? Perfect. He said subtract 23x. I'm digging that. Get that variable on one side. I get 7x minus 34 equals, be careful what's left over here. Negative 6. Watch your signs. And then, Decus, go ahead and just give me the last two steps for solving this. Add 34, and then divide by 7. Perfect. And if you did that, if you added 34, you get a 28 over here. And then if we divide by 7, we get a 4. Be careful. Would you get full points?
No.
Why not on this one? Yeah, it's like that other chapter where I kept saying, are we done? Yes, for some of them. But this one I had to go up and see it says to find RT. That's this fuchsia colored one. So I'd have to have somebody go do 23 times 4 minus 6. What do we got? What is it? 86. I'm hearing 2 of them, so I'll take it. Thank you. All right, I think we're ready to move on to working with the angles. I don't think we need another one. By the way, though, if it says perimeter, what do you need to do? Find all the sides. So in this one, you get x first, correct? But take a look at it. It's not as much work as you think, because what's the length of this one? You don't need to do any work. Thank you, 84, because it gave me the short one across from it. What's the length of this one over here? Double that, correct? 98. So really, I would just need to get this guy, and I'd set up my algebra, twice the short equals the what? Long. I'm not going to do it. Now let's go talk about the angles in here, all right? Actually, last hour they struggled more with this angle stuff. There's really no work to show. So you really are just going to be able to write the answers down, but it goes back to our chapter about two parallel lines being cut by a transversal, because that's really what's happening. So go over here, make that bold, put a little parallel line on it. You might want to take and extend it kind of, so you can see you have two parallel lines. We'll do it. They're actually parts of a triangle, but if we extend them, they're going to look kind of like our situation from, I think that was in our chapter 2. All right? When we cut them by a transversal, all these angle pairs up here, do you remember? They have one of two relationships. They're either equal, right? Like if this is 40, so is this one, so is this one, so is this one. Or they add up to what? 180. That's going to be your game over here as well. You're going to have parallel lines. They're cut by transversals. I've got one over here, I'm going to extend it, and one over here, and I'm going to extend it. So watch how I'm going to find these. Are you ready? Let's go look at angle 1. These two would be called same side interior. Alternate interior, remember that this chapter, you guys are good at it, right? Alternate interior, these are called same side interior. What do? Add up to 180. So to get angle 1, I'm going to do 180 minus the 127. I have 53. Okay, so I'm going to go put 53 in there. But now that you have a 53 in there, you actually know one of the other ones. Because in the other clump of 4, who's in the same spot? Angle 2. Do you remember what those are called when you're in the same spot? Excellent. I love this class. Corresponding. Yeah, so this is in the bottom left, so is this. Plus, don't they look the same? And I said, they're either equal or they add up to what? 180. Yeah, so angle 2 is also going to be 53. Let's go. You might need to point at it. I know yours is smaller than mine. All right, now I'm going to have to hop over on this other transversal. They gave me 59 here. Which one is also 59? Thank you, 4. Perfect. So 4 is out. It's kind of like a puzzle. I can get 5 two ways. Do you see them? Yeah, they add up to 180 because they're same side interior. Or 5 and 4 make a line together, correct? Either way, 5 has to be 180 minus 59. Yeah, so 5 is 180 minus 59. That would be what? 121. Perfect. So it looks like the only one I don't have, this was a 59 in here. All right, and this was a 121. The only one I don't have is angle 3. Up there at the peak. So I'm highlighting this in for a reason. How do you think I can get angle 3? Yeah, the angles in a triangle add up to 180. So if we take 180, you're already doing it for me, Isaac. Subtract these two, what do you get? 180 minus 59 minus 53. 68. All right, so I'm going to let you guys get a start on this one. Okay, you've got parallel lines. You might want to extend them. I had a couple kids in my last hour on Delta Math. They had an extension where they could grab a pen and draw on their screen. Do any of you have that one? I can't remember what they said it was called. And so they were taking the red and they were doing the parallel lines. And then they were heading over and they were doing the transversal in a different color. And I was like, well, that's helpful. I didn't know you guys had that extension on there. But they were just doing that, so they knew, well, I got to focus over here. And then once they did that, they're like, okay, they gave me a 118 right there, correct? Who can I get when I know that there's a 118 in there? 1 for sure, because it makes a line. And what other one can I get for sure? 1, yeah, 5. All right, so let's look at angle 1. We could just do 180 minus 118. That'd be 62. I'm going to go put it on there. 62. Correct? What other one is also 62? And we're only looking on that blue transversal. 5. Yeah, that if you color code it like that, it kind of forces you to pick the right one. So angle 5 is also 62. Now take a look at that picture. This one's a little trickier. I don't know 2, 3, or 4. Okay. I do know 3. What would it be? All right, let's go take a look up here though too. What do these three have to add up to? Yeah, let's look at angle 2. Isaac, can you do 180 minus 95 minus 62 for me? So we're going to use the two other chapters. 22, 23, he said. 23 right there, 23 right there. Once 2 is 23, what other one is also 23? 4. Yeah, they're called corresponding, like you guys told me. And how am I going to get angle 3? Adds up to 180. Yep, so I do 180 minus 23. So I think we're good with that. What I want to do, though, before I send you off to Delta Math is show you one that some of them, they were great with the side lengths. They were great with the algebra. A couple of them were getting these angle pictures, and I think they weren't reading up here. So when you get to Delta Math, read. What did I say? Read. Right? It says it's formed by connecting the midpoints. Right? I just screenshot somebody who was struggling because a lot of them, when they got to this question, it wasn't color coded. I clicked on the solution and screenshot it, so it was all black. So just know that. It says find the measure of QST. That's an angle, not a side length. What is it? Angle. You have to go look at where it is. Q to S to T is this one. You might say, well, it's highlighted. It actually wasn't on the original screen. I clicked on show solution so I could show them the color coding. So it says to find that one. So take a look at this picture. All right? You have your parallel lines. Here they are, right? The short side and the long side. And I'm over there on this transversal. And that's where I was telling you some of my, it was actually the 9th graders. They must have put that extension on in their English class or something. I don't know. But they were doing these in red, because that's what I did in class, and then this one in blue, and then they were only focusing over here, and then they immediately entered what? What's that one got to be? 42. They could see it, correct? So when you're dealing with the angles, you're going to say, well, where is it? Like if they ask you for one of these other ones, maybe if they ask you for this one, well, now you have a triangle up there. So you're going to, that one tend to